We had been looking at this game the last day where you have the tiles and you move the tiles around. So this here represents the empty tile, the empty slot, and you can move things around. Basically you click on something adjacent to the empty slot and you can move it around, and eventually, if you're lucky, you get to finish it, and yay. So we were looking at how the little bits of JavaScript you can string them together. I mean, there was no JavaScript in this that you hadn't seen before. It's just a question of putting all the pieces together to make it work. And we had looked at a number of functions. Most of the functions I had showed you, they put a lot of effort into not doing everything 16 times. Or 17 even. They're like all these different slots. So this one here, for example, we were using the letters A, B, C, D, and E to represent each of the squares, and there was a string that represented the order in which they appeared. And this function here was taking one of those letters and converting it to the appropriate file name. So the first letter, the first block was called A1, the next one was called A2, the next one was called A3, and A4, and then it went B1, B2, B3, B4, C1, C2, C3, C4. And we were going that way. The only exception was that the last one, the empty one, that was actually called empty.png. But doing something like that, although it's requires a bit of thought, is going to save you a lot of long, unwieldy code. So where were we? We were at the stage where we were able to, we looked at this way where you could map from a letter to a number. I don't know if we'd actually gone to displaying them all. This here was the swapping function. Let's look here at the thing to randomize the order of them, for example. So initially we start off with a string that has A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. And that represents all of the blocks being in their starting positions. So if we want to mix them up and randomize them, that's what this function is going to do. And so it generates a random number between 0 and 16. Doesn't quite get to 17, does it? No. And another random number between 0 and 16. And then it uses those two random numbers. It swaps. So like if this is position X and this is position Y, it swaps the character in position X with the one in position Y. And so we have this swap thing from before, where we're swapping two characters around. So it just takes two random characters and swaps them, and does that 10 times, which is plenty. I imagine after 10 times, well, I don't know. Certainly if you did it 20 times, it would probably be as random as it was going to be if you did it 200 times. You know, there's only so many times you need to do that before it's random enough. It's arguable whether 10 is enough, but it's certainly, looking at it, I think it's plenty random, I think. Now, there is the issue that after you randomize it, okay, this last piece of the puzzle has to be down here out of the way. If you look here, every time you randomize this, we leave this last piece out. Now I guess you could leave any random piece out, and then just check that when the person is finished, if everything is okay and the random one is in the, if the whole is whatever, blah blah blah. But we'll just leave that one out. So every time we randomize it, we're going to leave that one out at the end. So the last piece of code in the randomize function is just saying find wherever P is and swap that with the 16th one, with the last one. So then that means that P will always, the last piece will always end up in there. So otherwise it's completely random apart from that. Now, resetting the order is quite simple. The string that controls the order, we just reset that to A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, and we're done. We looked at the display tiles function, and this is probably the trickiest part, I think, because we are doing the get element by ID, but that's actually a variable. So every time we go around, it's doing the get element by ID of a different thing. And it saves us doing get element by ID 16 times. So you could take the first image tag and change that image to whatever, then do the next one and change that, and then go on to the third one and change that, and go on to the fourth one and change that. Would you imagine if you had, a 10 by 10 grid, the code would be very long if you're doing that. And so here we're generating the ID of the thing we want to change based on the loop counter. So the loop is going to count through slot 01, slot 02, slot 03, slot 04, slot 05, slot 06, slot 07, slot 08, slot 09, slot 10, slot 11, slot 12, slot 13. Let's display the tiles. Now, this here is checking to see if you're finished. In hindsight, it probably seems very long or very complicated, because I imagine if you want to see if it's finished, then wouldn't the string just be A, B, C, D, E, F, G, H, I, J, K, whatever? What this is doing is it's checking that all of the characters are in order. So it's looking at the first one and the second one and checking if the first one is less than the second one, and then it's checking the second and third, seeing if they're less, and then it's checking the third and the fourth. But it seems to me, in hindsight, that you could probably just compare the string that's controlling the position of everything, which in this case is, what are we calling it? Order. You just see if order is, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, then you're done. No? So anyway, so maybe this is more complex than it needs to be. Sorry, now I'll get back to that. Okay. Now, do me is the function that kicks it all off. So if you click on the first image holder, whatever actual image is behind it, if you click on that image object there, it'll do me 1, sorry, do me 0, or do me 1, or do me 2, or do me 3. As the case may be. No. Where's it gone? So, if you click on an image that is not next to the empty slot, well, you're not going to do anything, are you? Nothing happens. It's only going to do anything if it's adjacent to this empty slot here. So if this is the empty slot, if you click on this, it should do something. If you click on this, it should do something. If you click on this, it should do something. If you click on this, it should do something. No. If you knew that the empty slot was in position, well, let's do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the empty slot is in position 9. If you click on something that's, if you click on the image that's in position 8, well, then that's clearly next to the position number 9, isn't it? And if you click on number 10, that's going to be next to position number 9. Kind of makes sense, doesn't it? In general, if you're in position X, if the empty slot is in position X, then anything in X minus 1 or X plus 1 is next to it. Kind of. It's actually not always the case, but you could see how that would be the case, yeah? What about, though, this position, what about this slot up here? This is 9 and this is 5. What's the relationship between a square and the square above it? Yeah, it's minus 4. And what's the relationship between a square and the square under it? Plus 4. In general. So in general, if you have if the empty slot is in position X, then X minus 1 is next to it, X plus 1 is next to it, X minus 4 is adjacent to it, and X plus 4 is adjacent to it. Now at the edges it all goes a bit pear-shaped because this here, this slot, is not adjacent to this slot. But in general that would work. So we have a function here called adjacent to empty, which will come back as true if X is adjacent to the empty tile. Now, if you want to know if you're adjacent to an empty tile, well, then you need to know where the empty tile is. So we have a function called where is empty. The Q there in the order string, that represents the empty tile. So you want to get the position of Q in that string. So where is empty will come back with the location of the empty tile. Now, so this then is trying to figure out if the empty tile if X is adjacent to the empty tile. So if we subtract E from X, and do an absolute value of that, then that would tell you if it's one above or before. No, that's probably too clever, I think, maybe. Like, you subtract one from the other, you either get 1 or minus 1. You could subtract one from the other and say if it's equal to 1 or minus 1, then, you know, it's next to it. Getting the absolute value and then checking if that's equal to 1 amounts to the same thing. But there is some argument that maybe a bit cryptic. No. Here then, if X is less than E, then if the difference before them is 4, then it's true. Else if x, yeah, so basically this is doing it the long way then, where you subtract one from the other, and if it's like -4 or +4, then it's next to it. No. So you can see this is going to be wrong though. Can we see where it's going to be wrong, where it's going to go wrong?
The edges.
The edges, yeah. It doesn't work for the edges. So according to this logic, this is adjacent, this is adjacent, this is adjacent, and this is adjacent. So to complete this, you would have to code for that. But it's important to see that you do need some kind of logic. You can't, it would just be too complicated to say, if it's in position number 9, if x is in position number 9, the empty slot is in position number 9, then this and this and this and this is adjacent to it. If it's in 10, then it's this or this or this or this. If it's 11, then this or this or this. Again, you don't want to be doing the thing 16 times. So in what situations would you be at the edge? What do these slots here have in common?
It's equal to 0.
Well, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They're all odd. They're more than that, though. You takers? What 3, say it right now, Colin. What 3, 7, 11, they go up in 4s. That's telling us something. Is anyone meant to make the final leap? The mod 4 of each of these values is equal to 3. Yeah?
So you can say if the empty slot mod 4 equals to 3,
Then exclude whatever, exclude the +1. What about these here? Here, in this case, in the case of all these issues here, yeah, and these are 0, 4, 8, and 12. There's no getting away from mod. Mod is everywhere. Mod saves you work. No question of that. So to fix this, you'd have to account for those. And yeah, no. So that tells us if it's adjacent to an empty slot, more or less. So if it is empty, then we're going to do the swap. So we swap order, which is the string we've been using, the thing we clicked on, and the position of the empty tile. And then we do our display. Then we check if we're finished. If we're finished, then we swap the empty tile, which we know is in 15, with the left out tile, which we know is in 16, and we display them again and say yip-de-doo. And so that's all of it, I think. I mean, we kind of looked at it from the bottom up, and then we looked at it from the click down, really, and I think we've covered everything. And it's important to be able to do that, to take small pieces of code and to fit them all together and do something more complex. One of the things that makes this game easier than others is that it only really has one state. Like, the things are in various positions, but the program itself is only in one state, where it's my turn to click on something. If you take, for example, a game, you know that card game where all the cards are turned over, like memory, I think some people call it, and you turn over a random card, and then you turn over another random card, and if they're the same, then like you get to keep those. And they get taken off the table, and then you go back to that, and you can turn over another one and turn over another one. Well, that has a couple of states. Because when you turn over when you click on a card, well, when all the cards are laid down, that's one state. When you click on a card, okay, and it turns it over, that just turns that over. That's you're in one. Then you're in another state now. Then you click on another card, and turns that over, and then it's going to check if they're the same. And so, depending on the state of the game, clicking on a card is going to do a different thing. And so that can be trickier to do. Similarly with noughts and crosses, or tic-tac-toe. You know, there's your turn, then the computer's turn, then your turn and the computer's turn, or your turn and the other player's turn. But that would be easy enough to do, actually, that doesn't make a difference. So some games have states, and they can be a bit more tricky. So any questions on any of that? Anybody want some of the code explained again?
So we say that the position of empty tile
Mm-hmm.
on the right
Mm-hmm.
is +1, x +1, on the left is
-1. Yeah.
So, and the logic of the pair acts up is positive and down
Up is -4 and down is +4.
That's what we say they were.
Yeah.
According to what the pair, because on the mathematically on the
Well, we've called this zero, like this is position 0 in our string. The tile that's here is held. The image that's in here in this position is held in position 0 of that string that we've called order. So that string is the data structure that's holding the position of everything.
So anything above that minus below.
Well, this is position 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, 8, 9, 10, 11, 12, 13, 14, and 15, and then 16. And so initially, that's actually, right now, the string holds A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and Q. And this is image A1.png, A2.png, A3.png, A4.png, B1, B2, B3, B4, C1, C2, C3, C4, and empty PNG down there. Now, like I said, most people would probably immediately gone to use an array for that. And you could have had an array of strings that held the file names of the images. And that would have worked quite well too. And just then you're swapping functions. You wouldn't be swapping characters in a string. You'd be swapping elements in an array. But that would work fine. Can anybody think of any other games, you know, that you might be able to do like this in JavaScript? You notice there are no moving parts. You're just swapping images around. So it's good for card games.
How would you actually do that? Let's say, action puts a big dragon and upside down. How do you do that?
It's hard. One thing you can do is you can, just as you can modify any of the CSS properties with JavaScript, you could modify some of the location, the position properties, if you wanted. So you could, in the code, if this was particular position, say from the top of the body or from the top of the window even, you could modify that. There's also a thing called canvas, which is a little box on the page you can open up and draw things in. It's not very satisfying though. I might show you canvas, although I kind of promised Gary I wouldn't because he does that in the next module. But maybe for the people who aren't doing the next module, I'll do it for you. Any questions? So you should be able to follow that, really. Obviously, some of it requires explanation. Some of it's a bit cryptic. I sometimes give out to students for being too clever in their code, and that the person coming after you has to be able to read it and understand it. I think some of that might be a bit cryptic, but at the same time, it's the only way to do something like this without, having really, really long code where you do the thing if it's position 1, and then if it's position 2 you do the same thing again pretty much, and then if it's position 3 you do the same thing again pretty much, and if it's position 4 the same thing again pretty much. So you don't want to be doing that. So like you saw when we had the check letter exercises, that you could do it and say if x equals a, then thingy equals whatever. If x equals b, then thingy equals whatever. If x equals c, then thingy equals whatever. If x equals d, then thingy equals whatever. And that's just too long, and you need to be some way clever about it if it's going to work out efficiently. Any questions? Okay, I won't keep you so just for the sake of it. I'll see you in the lab so in a minute.